Thanks everyone for joining in for this third of our series of webinars on Energizers and electric fencing. I'm Byron Arnold and I'm a product manager for Energizers here at Gallagher in New Zealand. I work in Hamilton, New Zealand, and I'm responsible for everything to do with the electric fence that has electronics, so all of our Energizers and testers and other such products. And I guess I'm meant to be the product expert, so we'll see if I can impart some of that knowledge on you all today. Now, this session is going to be on earthing, and I want to do a little bit of a disclaimer before I get into it too much, that earthing is not an exact science, it's a little bit of an art, and what works in some areas may not work in other areas because of soil conductivity or soil moisture levels or other things, other variables. So because of that, this session is designed to give you the knowledge, arm you with the knowledge so that you can make the right recommendations to customers so that they can take the right steps on improving their earthing and fencing system. And so it's just all about understanding the big picture, what we're trying to achieve, and then hopefully when you encounter individual problems in the market, you can use the tools that we're going to talk about to solution might be. With the webinar software, hopefully a few of you have been in webinar sessions with me before, so you should be familiar. You can ask questions. Do so at any time through the presentation. I'm going to do about 20 minutes of presentation and then there'll be some questions and answer time at the end. So at any time, fire through the questions. It just sits in a little text box on my screen, and at the end I'll try and work my way through as many of those questions as I can. Don't worry, I won't name and shame you, so you can fire through whatever dumb questions you like, and I'll just try and answer as many as I can at the end. Probably another thing to make sure you're familiar with the software before I get too much further is if you're viewing on a tablet or on a phone, you can swipe between seeing the webcam, which you don't necessarily need to see, it's just me, or seeing the slideshow, which I'm going to show a few pictures and diagrams of things going on. So you can switch between the two. But the most important one to make sure you're aware of is the questions function. A little bit about what we're going to discuss in the next 20 minutes is I want to explain some of the terminology. We talk about volts and current or amps and joules and energy a lot with electric fencing, but I find not everybody has a proper understanding of what terminology necessarily means and what we're trying to use that terminology to mean in regards to electric fencing. So we'll cover those. Then I want to talk specifically about earthing and Energizer, why and how do you know if it's working, and then some discussion on fence loads, what are loads and how does that how is that represented in our Energizer performance, and how do we, I guess, classify one Energizer against another one, and I'll show a performance graph of the M1200i for that comparison. And then at the very end we'll do some Q&A. So I'm very fond of doing these polls with these webinars because it's a good way to make sure that everyone's a bit comfortable with the software. They can click a button and get around, and we can see how many people are paying attention. So the poll question is very simple. What do you measure to find where faults are on a fence? So what do you measure to find where faults are on a fence? And I'll be able to send this out to you so you can click on an answer. Now for this, I don't get any feedback on who selected which answer, so don't be shy. So what do you measure to find where faults are on an electric fence? Volts, amps, joules, horsepower, or all of the above? There's a few people yet to vote. I'll just give you another second. That's it. Throw in answers. It doesn't really matter. Okay, and I'll close that off, and I can share the results with you. Almost everyone voted. Thanks for that. Most people have said volts. A few of you have said amps, 29%, and 14% have said all of the above. The correct answer, in my view, is amps. Volts can tell you if a fence is working effective, but it's amps or current that you follow to find where the fault is. So volt will tell you if your fence is working or if it's not working, but it's current that you need to follow to find where the fault is. Oh, something clicked there. There we go. And we're back. So now I'm going to get into a little bit about what those terms mean. I've given you a brief understanding. Volts is it working or not? Current, you follow to find the fault. And then there's energy as well. And it's a little bit confusing. Well, I think it's a little bit confusing because we sell all of our Energizers on the stored energy, be it 28 joules, 10 joules, 2 joules, or the small solars are 0.1 joules. Yet that doesn't mean anything when you're actually using the device on the farm. So how do you correlate? And unfortunately there is no direct correlation. More joules means you'll get better performance on farm, and the only way to know how much is if you've got a 3 joule Energizer and you change to a 6, you should get better performance. So the best way to understand the fence system, I feel, is to think about it in terms of water and pipes. People can visually see water, so you get the, I guess, a bit more relation to what's actually happening. You can understand how if you've got a T-junction that can split water both ways, you can understand that visually, yes, it will split both ways, and the exact same things happen with electricity. So it's all pretty relevant to what we're trying to discuss. And so I'm showing a diagram here of a tap with a bit of hose that leads out to some pipes that have got leaks in them for watering a garden or similar, an irrigation system. And this relates very closely to the electric fence system, where the tap or the source of water is the Energizer, and if you only turn the tap on a little bit, that might be equivalent to a small Energizer. If you turn the tap on the whole way, that would be equivalent to a large Energizer, perhaps the M5800i. The lead out is represented here by the bit of hose that's linking the tap to the pipes, and you can instantly tell with a water system if the lead out hose is not of thick enough diameter, then it's not going to be able to carry enough water to the pipes to fill them to give enough pressure to water the plants. Exactly the same thing with a fence. If the lead out is of insufficient conductivity, which is the size of the pipe, then it's not going to be able to transfer the power to where you need it. And then the fence load or vegetation, plants growing on the fence, is represented here by the holes. The holes in the water's escaping is reducing the pressure. It's exactly the same as branches and grass touching the fence, which are taking some of the power and reducing the pressure. So with that in mind, hopefully it'll help you to understand the next few terms as I go through them. And the first one is volts. And this is, for most people, the easiest to understand and easiest to get to grips with. And I think of volts as putting your hand over a hose or a garden hose that has a little hole in it, and if the garden hose has lots of pressure in it, the water will spurt out And as you put your hand over it, you'll feel that. If the garden hose doesn't have much pressure, when you put your hand over it, the water's just trickling out and you don't really feel it. And so that's exactly the equivalent of voltage. If you've got enough voltage on your fence, when you touch it, you'll feel it. But if you don't have enough voltage, you won't feel it, or it won't be enough of a pain to contain or exclude animals. So having enough voltage is the most important thing to know. Is your fence going to be able to control stock? And at Gallagher we recommend that 3 kV is sufficient to control most animals. Some animals, sheep, if they're being grazed intensively or in a larger flock, you'll definitely need more than 3 kV to control them effectively. Other animals such as cattle, when they're being grazed reasonably relaxed in a larger paddock, you can control with as much as only 1500 volts, 1.5 kV. So it does depend on how intensive you're trying to graze your animals, how many animals you've got in the paddock, to what voltage you're going to need to control them, which is all based around how often the animals will want to challenge the fence. The next one is current, and this starts to get people confused because we talk about current, but it is measured in amps. So current is measured in amps, voltage is measured in volts. That's why volts is that little bit easier. So current measured in amps, it's the amount flowing past a point. In the image that I'm showing here, one is a high pressure hose and the other is a stream or a river. And the high pressure hose has very low current because even though it's high pressure, high voltage, it's only got a little bit of water flowing past a point, whereas the stream has much higher current. Lower pressure, but it's much higher current, more flow is going past. And so that's why we use current to find faults. Because when we find a fault, or we want to find a fault in the fence, we're trying to look for where the power is escaping. And so if you think of the example of the hose on the left, if going down the hose was 10 litres of water and you put a little hole and 1 litre of water came out the hole, you'd want to follow and find where that 1 litre of water is going to be able to fix it, to know how to fix your fence. Then the third term, that it has nothing really to do with volts and current in terms of how we fault find on our fence, but is the terminology we use to sell Energizers, because it's a pretty good way of comparing from one to another, is the energy. And there's two types that we talk about with Energizers, and that's the stored and the output. And I've tried to represent it here in the So stored energy represents how much the Energizer's got in capacity, and the output is how much it can, well, the output that we claim and other competitors claim is what the Energizer can output onto a fence that is matched perfectly to it. So it's the peak output. Of course, you need a lot of things to get that output right, such as you need the right lead out, you need a fence of the right load and all these things. So it's really to give you a ballpark guesstimate. How does that relate to water? I think of it as if you've got a big Energizer but only a small fence, then the Energizer's able to store all that energy, but it's only putting a little bit out into the fence and the rest of it is lost. It's equivalent of your dam overflowing and the water getting lost. It's not going through the channel of the lead out, which is why it's all about important to match your system together. It's a brief overview of a few of the main terms. It's hard to do this via a webinar system without knowing how much you guys on the other end know about this kind of thing, so I've tried to keep it very basic, and I've tried to explain it as you'd need to know these things in terms of electric fencing. So now that you understand voltage, which is pressure, and current, which is flow, and joules, which is your stored power, I want to look specifically at earthing. And so I'm using the example of an M160 here of how to make an electric fence. And an electric fence is really simple in that it is joining together the two terminals. And you're trying to close that gap between the two terminals by an animal. And the closer you can have an animal to those two terminals, the better shock you're going to be able to deliver. And so it's all about, in the image there I've got the two black lines showing the wire from the green terminal and the wire from the red terminal. Electric fencing is all about trying to reduce the resistance of those two wires so that you can get the most power to the animal to deliver the best shock. So here's an image showing a cow getting an electric shock from a fence, and it's completing that circuit. So we complete the circuit between the red and the green terminal by the animal getting a shock. And so the power here goes from the red terminal, along the lead out, along the hot wires. It shocks the animal, then goes through the animal and back through the earth to the earth stakes and back to the Energizer. So that's why we need to have earth stakes to help complete that circuit. The earth, the actual ground that we stand on, is part of the circuit that we need to give the animal a shock. So what do we recommend for earthing? This is where it is a bit of a guess, a thumbs up. We've got some recommendations that we say. We say the 4-3-2-1 rule, that you should have your earth stakes 4 meters apart. You should have 3 earth stakes as a minimum. They should be 2 meters deep, and you should use 1 continuous wire from the Energizer. 1 continuous wire to all earth stakes. So that's our general 4-3-2-1 rule. 4 meters apart, 3 earth stakes, 2 meters deep, and 1 continuous wire. It doesn't apply to all though. I've got an example here. I'll show you. This is one of our new Energizers, the S10. It's only 0.1 joules. So for only 0.1 joules, do you really need 3 earth stakes, 4 meters? No, you don't. You can't over-earth it in Energizer. Putting more earth on it is just going to be better. But to get reasonable performance from one of these, all you really need to do for the S10 is put the earth lead onto something like this. I'll step back so you can see. I've got just a ring top post here, which has only about 6 inches of steel that goes into the ground. It isn't a great earth, and if you're in an area of rocky or dry soil, you might find that this isn't enough, because that impacts on it as well. But if you're in an area of wet ground, you'd find certainly that that would be sufficient earth for the S10. The other rule that we use is you need an additional earth stake for every 5 joules of power. So for our M10000i, for example, which is 100 joules, you need 1 earth stake for every 5 joules of power. It's 100 joules, so that's 20 earth stakes, plus the initial 3. So for an M10000i, we recommend 23 earth stakes. Now I've been to farms where they've had an M10000i, and they've earthed it with only 3 earth stakes, and it's been performing reasonably well. And then I've been to other farms where they've earthed it with 30 earth stakes, and the farmer's unhappy because his earth voltage is still too high and he's still got problems with it. So you've got to know the area that you're working with and what's worked for other people in that region, and that'll give you a good guesstimate of where you can go. There'll also be times of the year, due to the soil moisture content, when your earth system will work really well, and then other times of the year where your earth system will struggle a little bit. Some examples here of poorer earthing. This is showing a B200 connected, a B200 Energizer connected, and there's the red clip, which is actually the earth, right on the ground in the middle of the photo there, and that's clipped onto the bottom of the netting post. And so this is a B200 with about 4 inches, 5 inches of steel earthed into the ground. It's a very poor earth. And when we saw this, we helped the farmer improve his earthing by driving a stake into the ground out into the paddock a little bit more where the ground wasn't so rocky. This is the side of a bit of a path through the farm, and so the ground is very rocky and wasn't giving a good earth, and he was using a very small earth stake. Now there's a bit of a question, what's better, to go deeper or to have more earth stakes? And unfortunately the answer is it's better to be twice as deep than have twice as many. So you are better to be deeper in the earth always than you are to have more and more earth stakes. And that's just because as you get down through different layers, you get more conductivity and your system will perform better. Now I say unfortunately because usually going deep is a lot harder than putting in more earth stakes. Usually you'll hit rock at some depth and you won't be able to go any further. So that's probably the main disadvantage, especially if you're fencing with a smaller Energizer. Can you have 3 very short earth stakes, only 5 or 6 inches? You'd be better off to have 1 earth stake that's 1 metre long if you can get it into the ground. Here's another example, a great earth stake for this B45 there, a great earth stake, but it's in soil that's very rocky, and you can tell from the image there, very dry, and so it was giving pretty poor performance because the ground was so dry. I've talked a lot about earths working and earths not working. How do you know if an earth system is working or not? Well, the easiest way to tell is to use a digital voltmeter, definitely a fence voltmeter, not a multimeter. An electrician's multimeter, you'd destroy it with the fence voltage. So use a digital fence voltmeter, and you simply put the earth stake from the voltmeter into the ground and then touch the measurement part onto one of the earth stakes. Now ideally you'd do it onto the earth stake that's the closest to the Energizer, because as you get further away from the Energizer it'll drop anyway. So you stand, if you can, 1/2 metre away from your first earth stake and put the voltmeter reference probe into the ground, about 1/2 metre if you can away from the Energizer, and then touch the measurement onto the earth stake, and that'll tell you how well your earth's performing. Ideally you want it to say less than 0.5 kV. So if you're getting a measurement like 1 kV, 1000 volts, that's a lot of loss on your earth. Most of our Energizers output about 7,000 or 8,000 volts. So if you're losing 1,000 volts just getting from the earth stake to in contact with the earth, then that's only leaving 6,000 volts left to go out onto the fence and shock your animals, which is enough, but you want as much headroom as you can so you can deal with vegetation and other things. So you're losing over 10% of your power, about 13% of your power, just trying to get earthed. It's often the most or the easiest way to get improved performance from a current electric fencing system is to improve the earth. I wanted to point out with our I-series Energizers we have a black terminal. Some other products have them as well. The black terminal is an earth reference. So you can see in the image there we've got a green, which is the earth, the red, which is the fence, and the black, which is the earth reference. The black terminal you connect as this diagram shows here. Terminal on the image is the earth. You connect to your earth stakes as normal. The black terminal you connect to an earth reference stake. Now this isn't really earthing the Energizer, so it doesn't have to be a stake of any decent size. It can in fact be a stake the same size as your digital voltmeter, so about yay big is reasonably sufficient. But you want it to be as far away from your main earth stakes as possible. 10 meters is fine, but ideally 15 meters or more away from your normal earth system. What the Energizer is then able to do is it will measure the voltage between your earth reference and your earth stakes. And so with something like the I-series, you can use the controller to quickly tell, is my fence working? And if it's not working, is the problem the earth? Because it's got that inbuilt detection of how well your earth is performing. One last thing I wanted to touch on, you'll see in this image the grass has changed from nice and green to a bit brown and dry, and in certain parts of the world where the soil conductivity is poor or the ground is dry all year round, and particularly Australia, they exclusively fence with what we call a live earth fence. So showing on the diagram there, the top wire is red, the middle wire is green, and the bottom wire is red. So it's a live earth, live fence. And the animal, if it only touches a hot wire, if it only touches a red wire, it might get a shock, but it won't get a very sufficient shock because the earthing through the soil is very poor. So the animal standing on dry ground isn't going to get much of a shock. But when the animal touches wire to wire, so from the red to the green wire, then it will get a boot, and that's called live earth fencing. And you'd still earth it as well to try and give the animal a shock when it's only touching the hot wire, but you're really relying on the animal touching wire to wire to get a proper shock. It's a lot more effective fencing like this, but obviously it's a lot more challenging because you've now got the hot wire and the earth wire that you have to run out across the farm. One thing I've missed a bit earlier is when you're testing your earth system, to try and load up the fence so that the Energizer is running kind of in its worst case scenario, as it would in winter when there's a lot of wet grass. It's just, or sorry, autumn when there's a lot of wet grass. It's just falling on the fence. And shown in this image here, this is in Australia obviously, and what this man is doing is he's putting a steel stake between the wires, so he's shorting from live to earth. You can, in areas with wetter soil, short of course just from the live wire to the using a steel stake or something else. And you want to do it ideally some distance away from the Energizer, and that will make sure the Energizer is adapted up, it's running at full power, and then when that's happening, then you check your earth, because that'll show you how well is, or how much power are you losing on your earth system under the worst case scenario when your fence is heavily loaded. Last thing that I wanted to cover is a little bit about fence loads and what are they. So an image here shows a fence, it's camouflage, a fence through high vegetation, and every single blade of grass that's touching onto the fence represents load to that fence. Other things that can load an Energizer are broken insulators or older insulators with moss and mildew on them, or perhaps old wire that's been left in the field and it's got tangled up in the fence. So with the understanding of vegetation, having a look at how different pulses travel along the fence and deal with the vegetation differently. This image is showing the Energizer and the earth stakes, which you've now seen and familiar with, and then a little bit of fence, which we're taking to mean a couple of kilometers of fence, ideally, for this example. Now, if you have a low energy pulse, you'll see how I've drawn on there on the diagram a red pulse on the fence. and I've drawn it very sharp. It's a low energy pulse, but it still has high voltage. So in S10, for example, this Energizer here still outputs 7,000 volts, but it's a lot less energy pulse compared to an M2800i, which is 21 joules. So the larger Energizer only outputs, an M2800i actually only outputs 7,000 volts as well, so they output the same voltage, but the pulse is a lot wider in the M2800i, and that allows it to travel better on a fence. And so here I'm showing a second image down the bottom with a bit of a wider pulse. And what I'm trying to illustrate is that on a very clean fence, the difference between the low energy pulse and the high energy pulse won't be that much. If you look on the far right of the screen, the amplitude of the sharp pulse is only decreased about the same amount as the amplitude of the wider pulse. Now the difference is when we add vegetation into the mix. So in reality, when a fence has got some grass growth on it, the pulse with the more energy will survive a lot longer. What the grass will do is it will start to take energy out of the pulse, so the pulse will become narrower and narrower over time, but it will still maintain a lot of its amplitude, which means the pressure over a few kilometres of fence will still be sufficient enough to give animals a shock, because that's what you need. You need the amplitude to be able to give animals a shock. So that's the advantage of having more energy in the pulse and to help deal with the fence load. It's quite a lot of physics, I guess, to get your head around. And then, and most of you have probably seen graphs like this that we've distributed and given out with our products and things like that. So this is an example of the output curve for the M1200i. Now the M1200i is 11 joules stored and it's 6.6 joules output, but as you can see, it's only 6.6 joules output at a specific load. And so that really doesn't mean much. What's the chances that your fence is working at that exact load? So what we try and do when we design our Energizers is we try and design it so that they output as much energy over a wider load band as possible so that customers get the best possible performing Energizer regardless of their exact fence configuration. And so what we've done is we categorized what size fence typically an Energizer would go on and what the normal load of that fence would be, and then we design the Energizer around characteristics to match with that load. So for example, you can see the peak of the 1200i here is happening at about 150 ohms, but the peak for an M10000i happens at about 50 ohms because we expect customers that are buying an M10000i to want to put that on a fence that's much heavier load than an M1200i. If I was to show the graph for the S10, which is very small in comparison, it's a magnitude of order, 2 magnitudes of order smaller than the M1200i, the output curve would be even more to the left, so that it's delivering its peak energy at about 2,000 ohms or 3,000 ohms. So it's designed for a much smaller fence, but it's designed on a much smaller fence to give effective energy. And then to confuse things even more, I'll throw in the voltage information there, and that shows, for example, on a 5-acre approximate farm, which might be equivalent to 5,000 ohms, the Energizer is outputting over 6,000 volts. Nearly 8,000 volts, which is the red line, but it's only outputting 0.5-ish of a joule. So it's not outputting many joules on a fence of that size. And it's when you get into a heavier load, such as 50 acres of fence that the Energizer's outputting, what was it, about 5 joules there. And at that load level, the Energizer is starting to struggle to maintain the voltage. And so the Energizer will now be running at full noise, and any more load that comes onto the fence, any more vegetation that grows or grass that gets wet or insulators that crack or break are going to start bringing down your voltage. So ideally we want, if you could size them perfectly, and the expense of knowing that is not worth doing, but if you could size an Energizer perfectly, you'd want to sit just to the left of where the knee is on the red line. So you want to sit just before it starts to drop, and that way if you have more load come on your fence, you've got a little bit of buffer, but really you've brought the right Energizer for your job. If you've brought an Energizer and you're way on the left side of this graph, then you've probably bought an Energizer that's too big for your job. And there is no problem with that, other than maybe you could have bought something a bit smaller and saved some money. For us, it would be a perfect world if everyone brought the M10000i, because it delivers the best performance on every fence. But everyone's got a budget and a fence size that they're trying to do, and so that's why the Energizers are tailor-made to the different sizings. So that's pretty much wrapped it up for me. I've gone a little bit over time, but fortunately there's no questions yet. Apart from one, can I do it in Dutch? I'm sorry, I only speak English. I'm Kiwi. We only know English down here. But this is the third and last of our webinar series. Before I get into any other questions and answers if they come through, when you go to exit this webinar, it should give you a survey. If you can just, I've asked 3 very basic questions. I'm not really worried about the questions themselves, but give us feedback on what you want to get out of these webinar sessions, how we can help you guys as dealers and our products a bit better, understand maybe what's gone into designing them, what the features of the products are, or perhaps we could do a webinar which is just a sales pitch to help you guys get across and understand the products a bit better. And then there's other things like this, education sessions on what electric fencing is. It's hard to know what level of education the audience is, how many of you are electricians and this has all been very basic, and how many of you gave up physics at the age of 13 because numbers and arrows did your head in. And there's a mixture of everyone, so answer the survey and let us know what you think and what you want in the future. Other than that, are there any other questions on what we've discussed, on anything? Well, that makes it a lot easier for me, so I'm going to go home. Thanks everyone for signing in, and I hopefully hope you got something out of it. If you've got further questions, feel free to email them through to me or contact your local Gallagher Europe representative. Thank you.